One thing we like to be able to do when we have two variables and we're curious how they're related, we can do the whole find a linear association, find that linear regression, and we can find that line of best fit. But then the natural question arises of, well, just how good is that fit that we found? When we're making predictions with it, is it a good idea to be making predictions with it, or is it maybe a little bit weak? So to do that, what we do is we use the correlation coefficient. The correlation coefficient is a measure of linear association between two variables, x and y. Now, to find that overall association for the entire population, we denote it with the Greek letter rho, and for the sample correlation coefficient, we use the English letter r. So we have r equals b1, our coefficient b1, times the square root of s sub xx divided by s sub yy. Now what this is it's the sum of the variance in our x values and our y values. So you'll note that I've written those equations off to the right here in green. So we have s sub xx, we're going to take each of our x values, find the difference of that with the mean of the x values, and we'll square it, and we'll add all of those up for all of the x values. We can do the same thing for the y values. We also need to look at the relationship between the x and y values. So we have this s sub xy. And in this one, what we're going to do is take each x value, subtract the mean x value from it, and then we'll multiply that times the associated y value minus the mean of the y values. So we have two different ways that we can calculate the sample correlation coefficient, one of them using that b1 coefficient, and the other way, we don't use that coefficient. So we don't use the b1. Now, perhaps even more helpful than the correlation coefficient is something called the coefficient of determination. The coefficient of determination is simply the correlation coefficient squared. Now, the correlation coefficient itself can range in value from -1 to 1. Anything really close to -1 is going to tell us there's a fairly strong negative relationship. Anything close to 0 will tell us that there's close to no relationship, and anything close to 1 will tell us there's a fairly strong positive relationship. The coefficient of determination squares that value, so it takes away the sign. So we don't know whether it's a positive or a negative relationship, but it tells us about the strength of the relationship. So the coefficient of determination, what it does is it expresses the proportion of the total variation in the values of the variable y that can be accounted for or explained by a linear relationship with the values of the random variable x. So if I find a coefficient of determination to be something like 0.24, what that's telling me is 24% of the variation in the values of the variable y can be accounted for by the values in the random variable x, that linear relationship that I found.